Welcome to another unit of the ISM Exercise Set Statistics 2, this time with a unit on binomial distributions. Let's have a look at the exercise. Back when interviews via telephone were still commonplace, so-called random number calling was implemented to assure that randomly telephone numbers are constructed and called. With this approach, the computer randomly selects a combination of 6 numbers that are called. So here we know we basically have 6 different numbers. Each number could be something between 0 and 9. Then, in addition, assume that in the city where it is applied, 350,000 valid telephone numbers exist. The computer randomly calls 5 numbers. So the size of our sample here is 5. Then we have 3 tasks. First, what is the probability that all numbers exist? Second, what is the probability that at least one number exists? And finally, during a day, in total, 20,000 numbers are called. How many of these numbers are not valid? So first off, we need to have a probability. The probability we get from the general information that in total, we have 6 numbers. Every telephone number consists of 6 numbers. So in total we would have 1 million numbers. Of these 1 million, 350,000 exist. So we have a chance of 35% of one of the telephone numbers to actually exist. As there's no information given that the computer does not call the same number twice, we can assume this to also happen, so the probability will be fixed during the whole procedure. So in this context, we have a fixed probability and thus have to use the binomial distribution. And that's what we're going to use in 3 different parts. So we start with the first part. What we want to have here is a probability that all 5 of the called numbers actually work. So we want to have the probability that x, or random variable, is 5. All 5 should work. The information we are given is, first off, the probability of getting a working number. And well, that's all working numbers, so all valid connections, that's the 350,000, divided by all possible number combinations, that's the 1 million. So in total, we have roughly 35% of working numbers. 35% of all possible numbers are working numbers. And we have a sample of 5 numbers, so that's our small n, which here is 5. Well, if we have this, we can simply insert this in the formula we have for our probability function, which will give us here 5 over 5. So n over k. The upper one is the 5 with the sample size, the lower one is the 5 we're looking for. Then we have the p to the power of k, so 0.35 to the power of 5, times 1 minus the p, so the counter probability, to the power of n minus k, so 5 minus 5. Well, 5 over 5 is 1. 1 minus 0.35 to the power of 0 is also 1. So we're basically left with 0.35 to the power of 5, which, if we put this into a calculator, gives us as a result 0.0053, or in other words, 0.53%. So the probability that all 5 of the called numbers work is actually, well, a little bit over 0.5%. Well, this already was the first of the exercises. In part B, we wanted to know what's the chance that at least one of the numbers exists. So it could be that 1 exists, 2 exists, 4, 5 exist, but not 0. So instead of calculating all the 5 probabilities and then adding them up, we could also use the counter probability. So just go there and say, okay, the only thing which is not okay is the 0. So we just calculate 1 minus 0, or minus the probability of 0 numbers existing. This will be the same as more or equal to 1 numbers existing. This also means we only have to calculate one probability, which is here the probability of x being equal to 0. So we have the same information as before, the same p, the same sample size of 5. We can enter these values then directly into our probability function of the binomial distribution, which would look as follows here, and would reduce to 1 minus 0.65 to the power of 5, or here 1 minus 0.116. So in total there's a probability of 88.4% that at least one of the numbers which are called also exists. Okay, this has then been part 2. In part 3, the question has been, how many of the 20,000 numbers which are called do not exist? Okay, we have the information that a number exists. The probability, that's 35%. So the probability of a number to not exist is 1 minus this. So this is 65% here. So we just have to multiply the 20,000 calls with the 65%, giving us here 13,000. So 13,000 of my calls, which I make every day, do not exist. So I won't get any valid answer from this telephone number. And well, this then already concludes the third and final part of this exercise. And I hope you like listening to it and you could take something away from it. If you're looking for more exercises, feel free to visit the rest of the exercise set or take a look at the corresponding playlist. I say goodbye and see you next time.